You're probably familiar with SPC graphs, but quite often there's a secondary graph underneath, the moving range or S chart. What are they for? Hello, I'm Tom. Welcome to my channel where we talk about continuous improvement in an industrial setting. And today's topic is that extra graph, the S graph, underneath your standard SPC control graphs. What is this secondary graph doing underneath our control chart? You don't always see it. It's also because it's not always needed, but it can really help you in certain situations to get a better grip on your process. Now let's start by saying that in an X bar and S control graph, the X bar chart is really more important. This displays the data of the midpoint of your process moving around. This is about the spread within the sample. This is the process. This is more the sampling process. But having said that, it can help you to identify things going wrong with your statistical process control process. Now, you will probably know that when we have a value outside of 3 sigma, or we see a couple of them outside of 2 sigma, this is a signal that our process has gone out of control, and we will likely have to do something. But also when it seems to be behaving quite well, there might be an underlying problem. Now, for that, we look at what is this S chart. And before that, let's talk about what is it actually saying. This S is the standard deviation of this sample. If you have a small sample here of a number of samples that you then combine into one data point, then you have an average of your samples. But that also means that one sample, one data point containing a couple of samples will have a certain spread, will have a sigma, a standard deviation that we can calculate out of that. And that's what's plotted here. Now, the way that this graph is built up is that you plot the standard deviation of each of your data points, and there is a upper control limit above which your standard deviation of one sample should not come. There can be a lower limit, but it's very rare that you have this in practical situations. Now, what you are looking for is that things are indeed also moving within the whole range of standard deviations that you expected, that you had when you set up the system under ideal conditions. And at some point, you can have that a sample goes over your control limit for the standard deviation within the sample. And that basically means that, well, you took a mean value, and these ones also came out quite low, but you took a mean value that may or may not have been within the control limits, but the individual samples within that group, that sample group, they were very spread apart. So most likely there is a spread within your process that should not be there, or something went wrong with your sampling. So it's also a reason maybe to exclude the sample point. But more dangerous is that within a very short time period where you would not expect any additional spread within the process, no variability, you actually got a very high standard deviation. And the other point that you can have is that for a very long time, and there are not too many strict rules for this, there are no definite rules for how long is this allowed to happen, because generally we don't consider it to be a very big problem. But if your samples really do not show any spread anymore, your process has changed. So it's not directly a reason to go change the settings or be worried about the process, but you probably will have to recalculate and redo your control limits, because when you get a much tighter sample, subset sample, than you had when you set up the system, probably you need to adapt to really still be in control. So this is for if you have subgroups of samples, so each sample point here is actually made up out of a number of physical samples. If this would be individual and you go to a moving range, then you are also looking specifically for something else happening, which is a sort of periodicity within your samples. In your main chart, you will probably see pretty low, then on this change, pretty high, pretty high, pretty high, pretty low, pretty low, pretty low, because this, in a moving range chart, represents that the whole of your data set switched, but did not switch back, because immediately after, there's almost no difference. So that's for the moving range. But to be honest, for an individual moving range chart, I like the moving range graph even less. The standard deviation graph of your subsamples, that one is a very nice addition to the main graph. Again, the main graph is the main graph for a reason. Make sure that this graph is well implemented, well understood, and has good control limits before you start moving into these more advanced tools within statistical process control. But I do think that it's important that we know what tools are available in our engineering toolkit, that we understand a bit what they do, why you would like to use them, and indeed for this one it will give you some extra ways to really steer your process and reduce variability even more. Now, if you like this little explanation of that secondary graph in statistical process control, don't forget to hit that like button. Also subscribe if you haven't done so already, and let me know in the comments if there is any part of the statistical process control process that you would like me to go in a little bit deeper. I'll be happy to share my knowledge. And for now, I wish you the best of luck with your statistical process control, but as always, also enjoy the journey.